Stop recording. Start recording. Hello everyone and welcome to Handmade Hero, show where we code a complete game live on stream. We are sort of, well, we just finished a little bit of a diversion that I had promised to show people some metaprogramming, so I showed some metaprogramming on the stream for 2 days. And it went pretty well. We got a little parser. It's kind of just a toy, but it shows kind of how to do that little cycle where you can parse some code, output some code, compile it into your game, and have it do stuff for you that could be potentially useful. So that's in there now. We didn't really have specifically any particular like overbearing need for it. It's not a crucial part of the project, but it was a reasonable place to do it, where you could kind of see how it was going to work and understand in a relatively confined context like what it could do and why. So I thought it was a pretty useful thing. But today I'd like to get back to finishing up sort of our debug output stuff because we still have several things we need to do there, and I'd like to kind of finish that up and get that into a situation where we can start using it more effectively for actually doing debug work. And right now we have some nice features in there, but a lot of stuff we just have not implemented, right? There's a lot of things that that need to kind of just actually make a push for being complete. And so what I'd like to do today is start kind of tackling that. Now today is day 208. So if you want to follow along at home, day 207 is the source code that you're going to start with. So please make sure that you unpack that into a directory, and that's what you're going to be working with now if you want to follow along with me. Okay, so here we go. Let's go back to where we were before we did our little metaprogramming excursion. So you can see, like, when we did the metaprogramming excursion, we did some stuff where we were like doing some automated debug printout stuff. So there's all this kind of nonsense here. All of that stuff was just in a little like piece of test code that we did and that I can easily remove here, right? It's this thing here where we did like test entity, right? This stuff. And so I'm just going to get rid of that. And when I get rid of that, then when I compile, all of that should go away, right? So now we're back to the standard thing that we were looking at before. And now we can also start to use, we had finished this thing where we could pick entities with the mouse cursor as well. So we can also use that. All right, so basically we have the ability to sort of print things out here. We have the ability to pick things with the mouse. And what we're going to try and do today is sort of consolidate things and work out exactly how we would do something where the printout comes from the app, not a standing structure. In the debug code, right? So what I want to do is I want to take sort of the stuff we were doing with the metaprogramming where we kind of just hackily sort of printed it out there. What I'd like to do is integrate that into this tree view stuff in some way that we could sort of, you know, pick an entity here, have that entity show up so that I can come in and, you know, do sort of the standard like expand and collapse thing as well, like all that stuff. I would like to be able to inspect things that way as we go, right? So let's figure out how we're going to do that, because that's a pretty big problem. It's a pretty difficult problem to solve, actually. As you'll sort of see as we work through it, there's a lot of subtlety there, and there's a lot of different decisions about how you want to make that work. So if I go over to handmade.cpp, we sort of had the beginnings of it here, right? As you can see, we've got this like debug begin element thing. So I sort of said, you know, here's roughly what I would want to have happen, right? I'd want to have something like this happen. And now that we have metacode, we could even do something where this was generated for us automatically. And like I said, now that we have a metacoding front end there, we could decide to do that. But that part is not really the part that's super relevant. Really, more the part that's relevant is the conduit between this piece of the code and the debug piece of the code, right? What I need to do here is figure out how I'm supposed to ever actually get at any of these entities, and so that's what we're trying to do here. So let's say that I was looking at this here. Now, what we do know is I could, if we were to look at this thing here, I could sort of look at this and say, well, there's this debug entity thing, and there's all this stuff that you might want to look at on it, right? You can kind of see all of this stuff here. And, you know, one way that we could deal with it, if all of these things were always in memory all the time, is I could just say something like, okay, here is an entity, here's a thing that I might want to view, put it into the debug stream. Because we've got the ability, right, like in our profile sorts of stuff, we've got this ability down on the, here, we've got this ability to like add these debug records, right? And whatever the debug records are, we could augment that debug record structure to store stuff like, here is an entity that I wanted to display, right? And so the problem with just doing something like simply sticking maybe like a pointer in there that's just a little piece of information, like here is the, here's the entity base pointer, is that something like, for example, even this entity, this sim entity, it only exists transiently. Like right now, we unpack the sim entity, we do the simulation, and then it goes away, right? And so really anything that the user could inspect in the debug view, like the programmer could inspect in the debug view after the fact, anything that's going to fall into that category has to get captured at the time that we pass through this code. It can't be inspected later in the debug system as sort of a walk in memory, because the memory is actually gone. Or more specifically, the memory's still there, but it ain't filled with this information. It's filled with something else, or just garbage, or who knows what. And so the question is, how are we going to actually deal with that problem? And I think, as you can see, if we jump back to sort of our mind space when we wrote this code, what I think probably we were going to do here is say, like, okay, instead of capturing all of the data that we could possibly ever want to inspect, which would be way too much data and very unwieldy and not probably a very good idea, instead what we could do here is say, oh, well, maybe what we could do is just capture like one selected thing, whatever like a selected entity is, like a hot entity or whatever. Select one of those and then capture all the information about it into the stream. That would work. So that's one way we could do it. And that appears to be sort of the way, like I said, that we were kind of going down before. It has some drawbacks, right? One of the drawbacks is that, if you were to pause a frame, like capture just a frame by itself, without the knowledge of what entity you wanted to know about on that frame or entities, you cannot go back and change your mind after the fact, right? You cannot go back and recapture other entity data because it has already happened. The best that you could possibly do in that circumstance is something like jump back to the memory state at the beginning of that frame, which we could save or something like this using the looped live code editing sort of system, and change what entity we're asking for at that time to get a different entity out, right? So that's something we could do. But something we can't do is just crawl all the data as part of the debug system. It's simply not possible. You have to continue to run sort of the game loop in order to have that happen. So, like I said, not sure what the best solution is to this problem in general in terms of the inspection. It's it's 6 to 1, half dozen of the other. And certainly, one thing we could do is say, okay, let's just go ahead and actually just dump them all. Another thing we could say is, in debug mode, when we do a sim region thing, we use this memory, and what we could do instead of having that be transient memory is we could actually have that be permanent memory, meaning when we do the sim region and we unpack all of our entities into the sim region that we're simulating, instead of going and throwing that away, we could instead save it to inspect it later. Okay, but even on top of that, again, getting back to some motivation of why we might want to keep doing it this way, though, is that even on top of that, we have a problem, which is that there would only be one state of the entity. So for example, if we wanted to know what the state of an entity was before it got simulated and then after it got simulated, so we could see like how its position changed, or what type it was changed, or things like that may have occurred that were changes in the entity from one point in time to another. Again, we can't do that with a system where all it's doing is taking the memory and inspecting it after the fact. So I think even though it has some drawbacks, I think at least for our current system, and with the understanding that on Handmade Hero we're not building the absolute best debug system in the universe, because the thing we're shipping here is a game, not a debug system. We have to be willing to accept a certain line in the sand of let's not try to solve every problem, right? Given that fact, I think the most reasonable thing to do is sort of stay with this kind of a system where what we're doing essentially is saying, okay, we're going to decide a few things to look at beforehand. We're going to capture the information about those things that we think is going to be relevant as part of the code. And in the event that that turns out to not be the data that we needed, oh well, we have to go change the code and rerun the test or whatever it is that we were trying to do. That's just the reality of the situation. It's still a lot better than debugging blind. It would still be a very useful system. Does it allow us to crawl the data arbitrarily? No, but then again, neither does anything else really until we finally get some real debuggers. And I would not hold your breath for that. So, that said, let's go ahead and push forward with this. And what I'd like to do is go ahead and say that, maybe this thing right here is going to essentially just go through this system, right? We've got this concept of debug records here, debug events rather. And these debug events have actually a type associated with them, right? And then they've got information. So what we can probably do, presumably, is we should be able to sort of, piggyback on top of that, basically, in order to dump data that we think we might need, okay? So I'm going to do that in sort of the simplest way possible at the moment, and, hopefully it will be something relatively, it won't be too problematic for us, basically. Okay, so here we go. I have a debug event, and I've got a type for the debug event. I can go in here and say that the debug event is now going to be able to output some values, right? And if we take a look at the values that this is outputting, right? Maybe we've got some things like we've got real 32s, right? Or U32s, sine 32s, that sort of thing. Yeah, that's really mostly the sorts of stuff that we would want to start with. We probably don't need to do anything else quite yet, because I'm trying to think if we want to store anything. We don't really want to bloat the debug event struct up too much because a lot of people are using it. But there are a lot of ways that we could get around that. So you could imagine, for example, us writing a sort of system for this sort of thing, where we actually did something, more like this. So as we sort of do the, we got a 64 and a 32 packed together there, and then here in the union, we could actually have longer things, and we could start encoding these with variable sizes. So we could have the type, for example, has sort of an understanding of a size that goes with it, and then we could have things in here that were going to be different sizes. I kind of feel like that might be a good idea to some degree, but I don't know, right? I'm not sure. Seems like it probably would be, though. And in that case, we would have things like this, right? So a bunch of our fundamental types would probably exist in here so that they could get captured as a whole, right? And again, that's really mostly about efficiency. That's not really about any sort of ability to capture, because we always could just pretend that everything is like R32, U32, S32, that sort of thing, right? And then in here, what we would do is we'd say, okay, well, there's V2s and V3s. We can't actually use V3 because that's actually a function we already have, so I'm going to have to kind of make up something for it there. But yeah, you could imagine something that looked like this. If we want to do something like this, right? Now, as you can see, when I create this union, it's going to take up more space. It's going to take up as much space as a rectangle 3, which is like 6 floats, right? Which means that it would massively bloat the space required to store the basic debug events, which is just like only 128-bit wide, right? Normally, like if you ignore this stuff here, normally it would just be 64 bits, 16 bits, 8, 8, and 32, right? So That is not good given the amount of debug information that we're currently pushing through the system. We definitely wouldn't want to do that. And so the way that I would handle that in the debug event is instead of advancing by a whole debug event at a time, I would always advance by whatever the actual size is of the thing that we're talking about. And then I would go like from there, I would then you know, both the reader and the writer would go, which type am I actually working with here? And whichever type that is, I advance by however much, you know, I need to as a result. So that's, again, pretty straightforward thing to do, and we could totally do that. We don't have to do it quite yet because we could just let this thing get bigger. You know, I could do this, and if I go ahead and do that, I guess that's not defined yet. I guess I could just do it like this. So we could just say, okay, you know, there's up to some large number of these, right? Since those all take the same amount of space. I think I said 6. So we could do something like that, right? In theory, that still works, right? So our debug stuff is very bloated now. It's much larger than it needs to be, but it would still work just fine. And so it's really just a memory compression thing is all that I would be doing there, is to make sure that we weren't using a bunch of memory bandwidth unnecessarily to sort of write these things out and work with them, right? So that I could do as well. And you know, I don't really know if that's sort of a good idea or a bad idea. I don't have a particularly strong opinion about it either way, but let's just say that for the time being, we just kind of leave it like that, and we see how it goes. So let's see here. Something like this. Maybe. Yeah, that seems reasonable. So if I've got something like this, now, you know, these things it should be fairly obvious that this is not particularly difficult to do at this point. If I want to record some stuff to the debug stream, it's actually pretty easy. All I need to do is define these debug value things to actually write to that debug stream, right? And so in order to do that, I could come in here. I think I might want to do this explicitly for the moment. I've got some reasons why I think I would like to do it that way. And especially since we have a meta generator now, I think that might be a good idea to do. I'm not 100% certain of it necessarily, but it just does, it seems, yeah, like maybe that's probably a good thing to do, potentially maybe. So let's say I go here to the actual code that we were looking at before, and I'm going to write it out manually for the time being. If I come here and I look at what we were writing out, you know, we've got a storage index. I'm going to go ahead and abbreviate these guys since this is the variable format that I want to kind of use going forwards. As you know, I kind of was experimenting with it a little bit to see what I liked the best, and this one was the one I liked the best. So if I take that and I imagine just sort of like sort of post-pending the thing on there, right? Like whichever one we're going to actually do here. I don't know that we really need to do that because we could use type discovery to kind of make that happen for us. But at the time, you know, I don't know that we really want that to happen. I'm not sure. We could do something like that, right? I don't know if we need it or not. I guess I could try without it first. If we were going to try without it first, the thing that we would have to do is inside our sort of our debug system where this stuff actually starts to happen. If I wanted to do it inside Handmade platform, right, then, you know, we've got this extern C sort of situation here. And that was something that we added for the benefit of people who are trying to call this code from other languages. And it would create a problem for us, basically, in terms of being able to use these debug value things in that way. Because we could not use function overloading in order to determine what kind of variable was being dumped. Whereas if we did force you to sort of specify what it was you were trying to dump like this, then it would still work from C. And again, I don't know that I have a super strong opinion about that. I'm going to go ahead and say that I don't really care about C linkage very much. I don't think it's a particularly valuable thing. And I was only, because I don't care if we link with C or not, right, at all. We're never going to compile in straight C because we have operator overloading and stuff like that. So I would say I would pretty much ignore this, and I might just say, like, okay, at the very end of all of this, we could even say if def C++ here, and basically say that, like, okay, inside our debug system, all of these things only get defined to be something else in the case where we actually are able to, to do so. So I'm trying to think of the best way to do that. It might be something like this. It might be something like, okay, if C++ is defined, if defined C++ and defined, what are we looking at here? If in our debug system is on, so it's like I think it's handmade internal, right? I never did like the way they do preprocessor stuff in C. It's so bad that we have a weak preprocessor. Anyway, so handmade internal, assuming that we're in C++ and handmade internal is defined, then you can get a bunch of these things. But if either of those is not true, then they just kind of disappear, right? But if they are true, then something like debug value becomes like, push debug value or something like this, or debug push value or debug, record value, I don't know, whatever you want to call it. And essentially what we're going to do is exactly this stuff up here, like exactly the same stuff that we were doing. The only difference is this stuff that's happening here is actually going to be like we're going to store different data. So you can see here, like inside this frame marker stuff, for example, we could do exactly what the frame marker does. So if I come in here and I say, like, all right, we're going to do the debug value call. There's the debug value call. It's going to look exactly like that frame marker stuff looks. So we create a synthetic counter to say this is where it's coming from. We record a debug event here, and we say that the debug event is going to be whatever the type was of that particular, whatever this particular thing is. In order to do that, unfortunately, we need some kind of like a cracking function. Like we need some way. This is why I was sort of saying it's kind of annoying. We need some way to translate a type into a debug event, right? So we need something like this, like where we'd say debug event from, and then we would pass it the debug value. So it would be something like this. There's the value, and I would say, get me the debug event from that value. We then have this stuff where we're like, okay, event seconds elapsed in it. That is the thing that was being stored previously. We are not storing that in this case, right? We are actually storing one of those other members, and we're storing the members based on sort of what we're actually getting passed. And in fact, I guess now that I think about it, record debug event common. Record debug event common. Where do we actually... Okay, so actually, that's not even true what I said. Record debug event common just needs to do event counter. It doesn't even need to do any macro stuff at all, actually. That's kind of nice. So actually what happens there is that can actually be sort of a function call sort of a thing. It's got the translation unit index problem here. I guess is one sort of nasty thing about it. But really, this is actually pretty reasonable, I think. So I think what we would do is say something like this. We want to record a debug event, and that debug event is, let's just say that we lie and say that it's, well, we could even just say that it's an R32 or something like this, right? So we tell it to do record debug event common. We pass something like that. And then in here, where we're actually going to set the thing, we'll like set event data, or something like this. Set like debug value set event data or something like that. We would just pass whatever the value is, and whatever this record debug event common ends up giving us back In fact, how do we actually, I guess it just spontaneously defines that right on the stack for us. Yes, that's what it does. Whatever event we have, we just pass that in there along with the value. And now this thing, debug value set event data, that's the thing that will do all of that cracking for us, right? So what we would then say is like, okay, we just have, you know, an infinity of these, where infinity is actually some very small number like 10. You know, it's not a particularly big infinity, but you know, not every infinity has to be huge. We just have one of these guys where we've got one for every type of value that we're sort of putting out there, right? So for every one of the debug event types that we've got, right, all these sorts of things, that's what we would do. Now, I don't actually know, that's not what I'm talking about. I actually want platform.h, I want this one, right? So I just want these guys. So yeah, I need to fill out this event for each of these different types, right? So there's the R32, right? It would take an R32 and it would say that the event, you know, vec R32 0 equals value, you know? And I feel like the rest of this is really pretty rote, you know what I'm saying? So there's like the v2, and that would just be something like this. Right? And that just kind of goes on ad infinitum. Right? So that would record, you know, all the different types of vecs we have. And then similarly, you know, we could do something like, all right, here's the U and the S type. And that's like S32 and U32. You know what I'm saying? And then, you know, if we want to do rectangles, those are, again, same deal. I got some rectangle value here that I want to store. And it looks exactly the same, only we do the min and the max. Right? And so that's really all I was talking about. We're now saving, you know, all of those values. Oops, wrong one. That would save all of those values to the debug stream so that we would be able to, you know, sort of memento them, like capture them, and be able to show them later. So that's really all I'm talking about. Second C linkage. Oh, we're still in the extern C block, of course. So let me grab this little guy here. There we go. So we need to put that out here. All right. I don't remember what we called these guys in the platform thing. Yeah, I don't know. It was vec S32 and vec U32. My bad. So it was that sort of a thing, right? Okay. So yeah, okay, so we also have a little bit of a problem there, whereas if we want these sort of automatic cracking values to happen, well, you know, now that I think about it, if we want these auto ones to happen, we don't really have to have these in here, right? We can just do it for the types that we actually do have defined in here, if we want to, and then, you know, we can sort of take those out. Now, there is a reason why we might want in the platform file to define those, right? Because they are kind of things that you could imagine the platform layers wanting to use. So I don't know, you know, if that's the best thing to do or if that's not the best thing to do. It's really kind of touchy what goes in the platform layer and what doesn't go in the platform layer. So I'm not certain what the right answer is there, but you can imagine, for example, just taking these guys, the ones that rely on other types, like that, they can be moved. So if I were to take these out and go to handmade math.h, you could imagine us just sort of putting in here, like, okay, the debug cracking functions for these guys actually could go, you know, right in the, you know, right with the code that defines them. So in the file that you define v2s, v3s, you get the debug crackers for those as well. You know what I mean? And that would work pretty well. So yeah, of course our handmade meta stuff, again, doesn't really have all of the definitions that it probably wants. We sort of had this thing where we're still using some of these older versions of stuff. I can go ahead and fix those just for fun. Yes, please reread from disk. Real 32 should be R32, so distance limit. There we go. That's what we're looking for. And where was our introspect? What else do we have? There's one. Get rid of that guy. Get rid of these guys. I should probably just do a day where we just get rid of all of those at some point. It should happen. And we also have one in Handmade World, right? We introspected that. So these are those as well. Okay, so someone's still using a Unit 32 here. I don't really remember who it is. There it is. There we go. Okay. So now we just got to actually get this stuff working. But that's basically, that's basically what I want to start with, is that concept right there, the way that we played it out. Okay, so now we got to make sure this stuff makes sense. We call record debug event common. We do whatever the stuff is that needs to happen there. We call debug set value data and that nonsense. We have, so there's our missing semicolon. I can fix that. None of the 7 overloads can do the hit point. That's correct. I'm going to start this off by not having arrays in there yet. So we can deal with that a little bit later. Same with that. And let's see. Okay, so now we just have to fix these little printout routines that were kind of the old printout routines that we were playing with. Like I say, might as well leave them in working order. Okay, so now in theory, anyway, we are actually recording these, and it does look like that's true because you can see we hit an assertion in here. When we're doing our debug collation, you can actually see that we get to the point where we have collated the frame and we're like, oh, hey, wait. We actually got to a sort of a situation here, right? We got to a type of event we didn't recognize. We don't know what it is. So, looking at this, I feel like what we could do is much exactly like the way we collated our other debug records. We can now collate these ones that are coming from the like these debug records that are coming from the game. We could reassemble them back into a structured piece of data that could be walked by the engine, right? At least it seems like that would be a reasonable thing to do. So yeah, again, if we want to, we should be able to build, some kind of like an introspectable, basically just build the actual struct set that we were doing before. We should be able to build that from the collation data. So the way that we have these sort of debug variables and stuff, the way that we were building them in here, where we sort of have like if you just look at this sort of, where is it, variables, the way that we were doing this stuff, we should be able to essentially build one of these, I would think, up from the, from the sort of parse that we get. So as we're kind of coming through here, when I see these various values, I'm going to go ahead and try just building one of these variable groups and seeing what happens. Now, there is a sort of caveat there, which is, again, there's really not a lot of... One of the things that we sort of set ourselves up for success for, but we haven't actually dealt with yet, is if you remember, debug values and debug things, they have this concept of an ID, right? So we've got these like debug variable links, and the debug variable links were things that had like sort of these IDs you could build from them, right? So when you were iterating over something, there's this notion of like an ID there, and the ID was something you could use to tell like which one you were looking at and stuff like this, right? And this is sort of the part that, like I said, is like kind of really subtle and going to be difficult, because if we are taking data every frame from the app and sort of reprocessing it, right? Like it's getting captured as part of the run of the app, so it has no permanent addressability in that sense. We're going to need a way to know how to talk about that piece of information in order for it to work with the rest of our debug UI. Because our debug UI needs a way to know that something exists from frame to frame, right? And since this is a thing that's entirely ethereal, we need to make up ways to have that happen. And like I said, we sort of set ourselves up for success by starting down the road of having this debug ID concept. So it will, I think, be very plausible for us to figure out a good way that we can use that to enforce exactly something like that, exactly a sort of stationary ID system that will allow us to sort of fetch those things back. But it's going to, again, be a little bit complicated. So anyway, let me see, where was I? So what I want to do here is I want to start to build up a thing that can actually be output as necessary from these things when we get, basically that assertion that we got. So when we hit the assertion, when we're inside collate debug records, I want to be able to start collating data records in addition to these other sorts of records that we have, right? Because you can see we've got like collation frame and collation end block and those sorts of things are happening. I would like to have something that was going to capture the other kinds. So we've got begin. Where do we have event type equals event frame marker? Then we've got collation frame. Assuming that we're on a frame, we've got begin block and end block. And so I think what I'll probably do is sort of move that out into sort of a more complete concept. And maybe I could leave even these the same as they are at the moment, and then assume that like this is the thing that handles maybe all of the other ones here. Although I could just do this. I could just do this right here. There really isn't much reason not to, I suppose. If I switch on the event type, I could just say that here is begin block, like so. Here's end block. And that is all we would need to do for that. Then we would have our default case here. And I think that should just do exactly the same thing as it did, right? That should just immediately say, hey, I got an event type I don't understand. And so then from there, we can sort of put in all of those other cases where we were trying to output some things like these guys, right? And so in here, I'm going to go ahead and say, all right, we've got, all these different cases that we want to handle, where we're going to basically just shuttle data back and forth like so. And so now if I just go ahead and let this not do anything, then we should just consume the debug events harmlessly. Nothing will actually happen with them, but everything still works okay. And presumably we are still able to view like the function profiles and things like this. So we know that all the rest of the debug events are still getting collated exactly as we would expect them to. So that's all good news as well. But now once we get to these, we can start to actually use them for something. And of course, in our collation, we know that we, as we were sort of doing that collation process as we sweep through it, we have this sort of notion of like open block and close block and that sort of stuff, right? We can kind of leverage that because we have like all of these notions of like what the thread is and all that stuff, right? So when we're in here, we already know which thread we're talking about. So inside that debug thread, that piece of debug thread information, we can have sort of this notion of things that are being built up, right? We can have a notion of data that is being captured. And so if we look at this debug variable stuff that we have here, really what we could imagine is saying that per thread, we could just have something like this, where all of the stuff we were doing before to build up debug variables could just do that exact process over time using our debug collation, right? And again, because this would be sort of a rolling buffer sort of thing, it would mean also that in theory, things could even cross a frame boundary, and presumably they would still actually work, right? in theory. Okay, so if we take that and sort of move a little bit forward with it. So, okay, so we've got one of these things and we want to start making like a, sort of a stack sort of a situation. In fact, you can almost imagine the open block thing is almost, we're almost doing exactly the same thing here, right? We're doing a thing where we open something up, we put data into it, we close it, right? And that may open in a nested fashion if we want to have like hierarchical data that happens in there. That would in theory just kind of work, right? At least we hope it would. Who knows? Okay, so if we want to do something like that, we're probably going to need at least a couple other things here. We're going to need something like debug event, open data block or something like this, right? And debug event close data block, right? So in exactly the same way that we've got these like begin block, end block things here, we would also have the ability to like open and close data blocks, which are not the same thing, right? They have nothing to do with performance or timing things. They're just like sort of opening a data region, writing stuff to it, and then closing it out again, right? And I'm trying to think. I guess this seems like the most reasonable way to do it. Yeah. So when we're doing this stuff, when we have open data block and closed data block, it's pretty much going to be something like, open debug data block. It's going to be this sort of thing. I don't know why we care about starting frame index necessarily, or if we care about starting frame index. We probably don't because it doesn't really have anything to do with timing. But we may need that for other reasons, I guess. It does come from a debug record, that's true. It does have an opening event, and presumably it would be chained exactly as these are. So it would look probably exactly like one of these things. The only difference is that in addition to this stuff, it would have some kind of another pointer kind of on it, right? And so it makes me think that probably we would just want to reuse that code as necessary. So we would have something like, okay, we've got first open, code block and first open data block or something like that. So you can imagine saying like this sort of a thing, perhaps, and then forcing this stuff to kind of understand both of them. So if we have first open block here, I got first open code block and first open data block. This stuff would all be first open code block. Keep on going. First open code block. Yeah, let's see what else we got here. Where's my cursor? There it is. This would also be first open code block. Let's see, first open code block. First open code block. First open code block. First open code block. That's actually it. So these just need to get put on there. So if I take a look at Handmade platform.h, right, we just need these two different events that we have now, and we can also even write those in there because I believe we actually have, yeah. So inside Handmade debug, inside handmade.cpp, where we're doing this, I'm going to change this just for a moment. I'm going to actually make it so it's more like this, where it's like Handmade, it's like debug data block, or begin data block, something like that. And then this will be like debug end data block. And that's just sort of, that's something that we could wrap in one of those like little like utility classes eventually as well. And yeah, so I think that should probably do it. So if we did it that way, if I go ahead and put these guys in there, if we do begin data block this way, again, this would be just sort of a very straightforward thing. I'm going to eat the parameter for now, but it would do exactly the same thing. as say this function does, as the values do. But instead of this stuff, you know, these don't really have any useful names, I suppose. I don't even know. I guess we could give that a name of whatever the parameter was here. Yeah, we could, you know, we could say something like value. I don't even know. But we could, for example, stringize whatever they point. So, you know, if this is entity, then it's entity. We could also do something where we pass two things here. So, you know, we get a pointer that we might use for something, but we also have a name, which is like, you know, hot entity or something like that. So we actually have a name and a value to go with it, and we store the name here, and we do something with the value a little later on. So instead of having to do a function to crack this, obviously we would not have to, because we know exactly that it's always just a data block opener, and that's a pretty straightforward thing that we would do. And so in here, when we're taking a look at this stuff, like with event type, we know that this is going to just be open data block. In fact, I guess I don't even have to set the type, because I can now use that function properly, like so. And when we're recording the value here, you know, probably what we would do is record like pointer, or, you know, or ptr 0 equals whatever that is. So, you know, it's a way of kind of getting that piece of information there. And maybe we would do something like pointer 0, pointer 1, and those would be stored so that you kind of would get like basically a debug ID out of it potentially, right? So you could imagine saying like, oh yeah, so what this thing is, you know, we want some kind of a stable addressing thing for it that we could use a little more reliably. And so, you know, maybe we've got, if we take a look inside handmade.h, I feel like we have ways of accessing a low entity, right? Low entities have an actual index. So we could pass something like whatever that low entity index actually is, which we should be able to get from in here, right? Let's take a look. Let's take a look. So here we are looping over our sim entities, right? And if we look inside the sim region thing, we've got sim entity. And I assuming the storage index there is the guy that we actually need to know, right? If we take a look at what storage index actually does, empty by storage index, get hash from storage index, blah, 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 blah. Yes, whatever. There we go, right? So no, it's still not there yet. Add entity storage, add entity raw. There it is, right? So you can kind of see that storage index is something that's going to be stable over time, right? It's an index into that low entities array. So in theory, right, we could do something like that, where when we, in handmade.cpp, when we do begin data block, we could say that we know is a stable thing for it. And so then all we really need to do is say, and in fact, I guess we could even go one further and say, that's the stable index of this thing, right? That's like a stable pointer that will be the same over time. And then the other question is, well, there could be multiple things that are going to have that piece of information associated with them. And so we might want to say, like, this is the hot entity or something. This is a specific thing. So we could give a second guy here that is something like the hot entity pointer. You know, like we could introduce some kind of synthetic stable thing that sort of differentiates between these two. So, you know, something like hot, this would just be like hot entity nub or something. It's a funny phrase. But something like this, oops. And all I'm doing here, right, is I'm just making a little trick, which is to say that if I wanted to give the debug system something to like stably identify the thing that I'm talking about across frames, then I know that I have a stable way of referring to which entity it is, because every entity has a low entity index that's stable over time. That's where it's like stored persistently and whatever. So I could use that. But that doesn't necessarily tell me what part of data I'm using about the entity. So what I'm doing here is I'm just passing some value that says, hey, here's an arbitrary pointer that's stable that just differentiates this from potentially some other call, right? Now we don't really need to do that because we have that whole counter system and stuff, and the name hot entity is probably sufficient as well. So in theory, do we really need to do this? No. But since we got 2 pointers, maybe we use 2 pointers. I don't know. But yeah, so I don't know. So we could alternatively just do that because that, is basically saying we don't need the second pointer, even though our debug system allows like 2 pointers for an ID or something like that, right? So anyway, here's our debug begin data block. That is really all there is to it. Nothing particularly fancy, obviously. It just does its little thing here. And then when we do debug end data block, I'm going to go ahead and essentially make the exact same thing here. Debug end data block is going to be the exact same thing, only this time you're not going to pass the pointers because you know that the debug blocks have to end in order. That's just the thing we'll say about our data blocks, so that's fine. So it doesn't actually have to have any data. It's just sort of saying that the block is closed, right? And then I think we should be mostly set. There shouldn't really be anything else too bizarre about that. So inside, so this is like a vector of pointers inside here in our handmade platform.h. We would have to add that to this, right? So vec pointer, and maybe there's just 2 of those. I guess technically there could be 3 of those. That's how many there is space for currently. But anyway, debug and data block. That is correct, right? Yeah. So inside debug data block, we don't really need a block name for the end because again, it just kind of pairs up automatically. So I think that's totally fine without actually having one of those, and off we go. So we also have to deal with these guys here, debug begin data block and debug end data block. Those are the ones that are just kind of when we compile out. I still want to be able to compile everything out if necessary. Okay, so I think we're in good shape now. These guys should be ready to go. And so really all we need to do is inside our open data block and closed data block correlation system, we need to have a way to actually start recording some of that data. But we're just about out of time, so I'll probably stop soon and go to Q&A. I don't know that we will have time to kind of get this stuff in here. But what I can do, since we're going to be reusing this open data block concept, what I can do is just sort of pull out this code that I'm going to need to do that with. So I'd have a thing like this, which is like debug open block or whatever it is. Let me just grab it right here. This thing. So if I have an open debug block, this is the thing that would like get me the next one. So like allocate open debug block, something like this. And what this would do is it would just say, okay, from the debug state, if you need to go ahead and get a new debug block, you just pass the debug state in. It will look for the first free block. It'll see if it can get it. If it can, it will use it. If it can't, then it will just go ahead and make a new one out of that collation space, right? So that's really it. Oops, that's debug state result. There we go. So something like that, right? And if I then go in here and just replace that where we were doing that previously, like this stuff right here, I can just have this with allocate debug block or allocate open debug block. That gets rid of all of that code that would have been duplicated because I'm about to have to do that exact same thing for my my other open and close block. So in here, when we do the first open code block, debug state, first free block thing, so this right here, you can see the first free block, first open code block. This is also that same sort of thing. This puts the thing back on the free list, right? So this is essentially like a this part right here is essentially the deallocate one, right? So I could have the exact same thing, deallocate, open debug block. Here's the debug state. And if you take a look at how this code works, again, really, really simple. We're just saying whatever the block is that we're trying to free, it's going to be whatever the first free block was, and then the first free block itself is going to become the pointer to that block, right? Oops, open debug block. Right? So if I go ahead and do the deallocation here, I replace that piece of code with a known thing. And again, that's really just me being proactive because I know I need to do it. So I'm just going to do it. I would have had to write that exact same code for these guys, so I don't want to write the same code twice. There you go. So all I would do is say, hey, thread first open code block is the block that needs to get freed, and we're done, right? That's a pointer. There we go. And off we go. So again, no change here now. It should be exactly the same as it was previously. Let's just make sure of that, and there it is. So that's all good. So yeah, so I think we're all fancy now. Okay. So I'll go ahead and go to the Q&A here. In case anyone has any questions about what we did. Again, we're kind of just like getting prepared to capture all that data, which we'll try to do tomorrow. Again, from the debug log, and then we'll kind of go from there. I'm going to take off the old wrist guards. All right, let's see. Could you explain how this code works? It's fast inverse square root. I still have no clue how it works. Let's see. Float q reciprocal square root. 3/2, x2 number equals 0.05, y equals number, I equals star long evil floating point bit level hacking, OX57375 df I square root down / okay. Okay. I guess what I would say about that is, no, I probably can't, at least not right off the top of my head. I can sort of give you a clue as to what it's doing. There's some pretty standard techniques for this sort of thing. And it looks like it's using at least 2 of them in here. So basically when you compute things, and we'll see a little bit of this later on Handmade Hero, when you compute things in a compute horror that are complicated, such as square root, sine, cosine, tangent, whatever, transcendental functions, and things of this nature. Typically what you do is, the way you compute them is you use like series expansions in one case, right? So you have like things like Taylor series or series expansions that are series that will converge to the answer. So you'd make like a series, like the old school kind that you did in high school or whatever. You'll do like a series expansion where the series creates the mathematical function that you were interested in to a certain level of precision based on how many terms of the series you sum. And then you actually just do some number of those in the series and compute it, right? Another thing you do is you do what's called root finding by, say, Newton-Raphson or things like this, which are techniques where if you have a function and its derivative or multiple derivatives, depending on the circumstance, you can start out with a guess that you think is close to the answer you want, and then you can run this to refine the answer to get it much closer to what you wanted, right? So what I see happening at the end there, and I have to go, like I said, I'd have to work it all out myself to really know what it's doing. But what you see at the end there is just some kind of refinement, like a Newton-Raphson iteration step or something like this. It's an iterative refinement where you're taking a guess and you're moving it closer to the actual solution, right? And that's very, very common in floating point function computations. If you really care about this sort of thing, I've said this many times on earlier parts of the stream. What you want to do is read this guy's books. They're extremely, extremely good. And I don't know if maybe there's like a good oh man, I don't like being reminded that Foreman Acton is dead. All right. Anyway, we'll ignore that for now. If you look up his books, they are all about how to construct routines that are doing these sorts of things, using series and refinements and stuff. And he kind of walks you through. In fact, it's I don't want to call it the handmade hero of real math computing, because I feel like his stuff is a lot stronger than mine, certainly. So that might be a bit of an insult to Foreman. But point being, his mental state is very similar to ours in the sense that people do all this kind of crazy math formalism and stuff, and it's a disaster, and he goes and looks at the actual practical way that the math works, like really underneath, and goes, this is how we would actually compute this thing. And so if you like Handmade Hero and you like math, you will love these books. They are very good. And they talk about those sorts of things. So if you really want to know more about that kind of that part, that's what he would talk about in here. Now, the first part of this function is not really something that Foreman Acton probably would talk about very much. The first part of this function, where they're casting the float to a long and then using a magic value to deal with stuff, right? What's happening there is floating point numbers, like any other number, is just a collection of bits. And the bits are in a known layout, right? There's a sign bit at the top, there's a exponent, and then there's a mantissa, right? And the sign bit says whether it's positive or negative, the exponent says what the scale is, and the mantissa says what the actual value is. You can imagine like scientific notation, right? It's the part where you've got like something, 1.239 whatever blah, e something, 20 is some scientific notation number just like you learned in school. Well, the e something, that part is the exponent. The 1 point blah blah blah, that's the mantissa. The 1 is implicit in floating point. You don't have to actually store it, but point being, that's the mantissa. And then the positive or negative, like if it's positive or negative, that's the sign bit, right? And that's how floating point numbers are stored. And so what you typically will see when someone sits down to really over-optimize a floating point routine, oftentimes there are certain operations that they need to do which can actually be done much more efficiently by actually just manipulating the bits directly. And so the I shifted down by 1, right, is whatever they figured out, shifting down by 1, which shifts like 1 bit of the exponent like into the it shifts 1 bit of the exponent down into the mantissa, right? And shifts the exponent down by 1. It shifts a 0 into the sign bit, but that's okay because you know that the sign bit was positive because you can't take the square root of a negative number, right? That's already off the table. So that operation, then using this magic constant, which they carefully constructed to do exactly a specific thing when you did the subtraction, will put like the number into a state that would have taken them many floating point operations to arrive at potentially. So it's just a way of going like, oh, okay, I figured out that the set of operations I want to do, like I want to like divide this number by 12 or something, and I figured out that I could do that by like actually like using a magic constant and subtracting it and whatever, right? So that's like how the first part works. And like Usually it's a lot easier if the person who actually wrote the routine notated how they arrived at that constant. But in the case, if you're trying to really reverse engineer something that you've literally never seen before and you're not familiar with where that constant comes from, you're going to have to do some wackiness by watching what happens to a floating point number when it's subtracted from that. And that actually shouldn't be too hard for you to do. You should be able to plug some known floating point numbers in that are easy, 1, 1.5, 1.25, things like this. Look at what happens to them, and you'll be able to see the operation that they're simulating by cheating like that, if that makes sense. So that's all, hopefully that's enough of an explanation to get you started on that. Like I said, I'm not going to spend time trying to reverse engineer it because that sounds like a lot of work. And we're probably not going to be able to do it on stream. It's not the kind of code that I work with very frequently. It's possible that if you ask someone who often does floating point optimization stuff on this with bit twiddling, they would recognize that constant. It may be a common trick constant. Some things are common trick constants, some things are uncommon, right? Some things are trick constants that are used in many places. Some things are constants that you made up just for this one algorithm that you want, and you're unlikely to appear anywhere else. And so that's just, again, something to be aware of. You could also search for it, but I doubt, that's probably not the most useful thing to do, but just for fun, it does not look useful. 5F3759, oops, 59DF. Oh, so there you go. In fact, you can see right here. Oh, did you actually get this from here? Well, wait a minute. They are explaining it right here. Why are you asking me to do this when the explanation is right here? Yeah, so, I guess this is good, though. It's exactly what I just said it was, right? So they're just trying to do a fast computation that they sort of worked out that they can do that really quickly. So they're producing 1 over the square root of x log 2, right? And they're doing that because using this magic constant is a way to do that much more efficiently, right? In their terms. Now, of course, it's when I say much more efficiently, this is from the old days, right? Because as they're even telling you right here, nowadays you can get the square root. The processor can do it basically for you. They've got square roots kind of built in. So it'd be kind of stupid to actually ever be using this thing, but it's a useful exercise, so it's fun to still, I would encourage you, if you actually are interested in it for some reason, to go through and actually watch it work that way, so you get some idea, right? What would be a good project for a beginner game programmer? Just a really simple game. I would recommend Asteroids or Space Invaders. Probably Asteroids is the very easiest. I would say that everyone should probably make an Asteroids game. I made an Asteroids game when I was little. It's a very simple thing. There's no contact, there's no support services, there's no obstacles. It's like one of the purest games you can make in terms of the simplicity and the directness of it. So I would say Asteroids. Make a good version of Asteroids. Get that going. Understand it all. That's a really solid place to start, right? Blah238, I just read that Natural Selection 2, for which Unknown Worlds made their own game engines, say they no longer support Windows XP. Does Handmade Hero run on XP, and why wouldn't it? So Handmade Hero, I don't know whether we'll run on XP. I don't know whether we'll bother running on XP when we ship or not. We would run on XP just fine regardless, except for one very specific thing. And that is whether we support 64-bit only or whether we support 32-bit and 64-bit. If we decide that Handmade Hero is 64-bit only, then it will not support Windows XP. If we decide that we will be supporting 32-bit as well, then it will support Windows XP. And you can see that we already made sure that we do run on Windows XP way back when, right? So if you go to our, oops, that's not what we wanted, handmade.org. That is Handmade Con, handmadehero.org. If you go to the tweetbot, no, I'm totally confused right now. The forum site. If you go to the episode guide, you should be able to see in sort of this the platform stuff. There's a thing where I actually test running on Windows XP. I don't remember exactly where we did it. Let's see here. I don't actually know. I'm not sure where we did it. But it was somewhere in here, I suspect. Here it is. So here's
Windows XP.
You can see us testing it on Windows XP, and we go through, and I demonstrated like one of the main reasons that you might not run on Windows XP. I showed like what you would do with it, which is how to like set the linking flags correctly and stuff. And then I showed us running on Windows XP. Right now, we would not run on Windows XP, and the reason for that is we allocate a big block of memory to store all our debug stuff and all this other things. So right now, we are not 32-bit compatible. So right now, we would not run on XP, but that's the only real reason. Everything else we do, we could run on Windows XP just fine. Now, as for the reason why Natural Selection 2 doesn't run on Windows XP, I have no idea. Could be because they require DirectX 12 or 11. It could be, because they require some audio system that's not there. It could be because they require 64-bit. I really don't know. I really don't know. Is that it for cues? I don't think I missed any. I think I got them all. Have you used the new Steam controller? What do you think about it? I have not used the new Steam controller, no. I have played with the old Steam controllers, meaning the ones that were, maybe a year ago or so. And they have changed it since then. I did not super see the point of it, to be honest with you. I didn't really think it was all that usable for playing keyboard and mouse games, so I wasn't really sure what the point was. Like, I was like, I can't see anyone actually using this for that, so it just seemed like a really bad gamepad. It was like, this is going to be really bad for anything that you want to use the gamepad for, and it doesn't actually work for playing anything else, so I don't know why it exists. But, I haven't used the latest one. Maybe it's like way better. I don't know. Let's see. Updates to the tool chain, the set of tools used to produce NS2, like Microsoft Visual Studio, have made it effectively impossible to keep running NS2 on Windows XP. A choice must be made between stopping development of the game so that it may run on Windows XP in perpetuity, or maintain development on the game, which causes Windows XP compatibility to fail. Interesting. So yeah, I mean, it sounds like, again, in typical Microsoft fashion, they just for some reason keep doing all this ridiculous stuff that makes life harder for everyone. You didn't get anything for that, right? They just broke it to break it because they, do that sort of thing. Soy Sauce the Kid, numerical methods that work. This is the book you're recommending, right? Well, actually, I recommend anything by Foreman Acton. I guess I haven't read them all, but I read Real Computing Made Real and Numerical Methods That Really Work, or that usually work. Numerical methods that usually work. And they were both really great. I could stand to read them again these days, actually, because a lot of that information has gone out of my head, because it's not the type of code that I write very often. And there's probably a lot of things that I do that honestly would be better if I kind of knew what we were doing there. But yeah, so either book, I think you would be good to read. Pseudonym 73, that is a great statement. Everything that runs on Windows P runs on Windows NP. That is so true. That is so true. It's also true that you could probably verify that you could probably verify the output of any Windows NP program on Windows P. You just don't know whether you could produce the output or not. Nobody does. Elvin, any tips on reading books? I find it really hard to read them. I do enjoy their table of contents. Gets me excited, but when I read on, it gets quite boring. I do not know how to answer that question. I like Chronal Dragon's answer, actually. So my recommendation for reading books is that if you're talking about reading programming or more importantly, math books, I guess what I would say is math books are often written by people who do not know how to communicate anything to anyone. Foreman Acton's books are unusual, actually, in the fact that they are very well written. He's actually a decent writer. But a lot of math books are written in a way that it's pretty clear that nobody who actually doesn't already know math extremely well will ever understand them. And it's not necessarily, there's no reason for it. It's just because math people just don't know how to communicate ideas very well. I think it's because they're so used to thinking in terms of math, they think that just by listing a bunch of equations is the most efficient way to get a point across, but it rarely actually is. And I feel like a lot of times there's people who know a lot of math but don't actually know how to use any of it because of that. It kind of exists in this vacuum. And so, usually the best thing to do when you're trying to succeed at reading a math book is actually to go try to find someone who crosses that bridge a little bit, because every so often there are people who are both good at math and good at communicating, and those people write books that are much easier to actually get into. Now it's still a very active process. Reading those books is still active. You have to do the actual exercises in the book. You have to, when they show a derivation of something, work it out yourself on the side. Because otherwise it'll just go right through you. You won't actually get any of the information, right? But it's really just 99% of the success is finding the right book first, because a lot of people write these books that are just wastes of paper. They're just big reams of the math behind something, and it's nope, you don't need to write that. That's complete waste of time, right? You don't need to just have a book that's all of the math. The important part about writing the book is structuring that math with explanations that allow it to cohere, So you gotta seek those out, and they're hard to find. And so I guess I would say, you know, it's not easy, but look for recommendations and ask specifically about that part of it. Like, is this actually explained well, and does it sound like the person actually knows sort of the like intuition behind this, or are they just regurgitating a bunch of math that they learned to do in college or whatever, right? And that's really all I can say. And no, I actually have not read Linear Algebra Done Right by Sheldon Axler. I think let's find out. So when is the first edition? You gotta, where is the first edition? Corrected printing, 1997. So ironically, it was published the year after I learned linear algebra. So that would explain why I have not read it. It was too late. But, you know, my linear algebra is so rusty these days, I could go read it and I would probably like relearn a lot of stuff that I have forgotten. So maybe someday I will read it. How do you deal with some of the generally poor social skills in programming math fields? Noticing this more and more lately, unfortunately. I guess I don't. I mean, I don't have to. I mean, I program more or less by myself. I work mostly with artists. And while it's true that some artists, you know, artists are also probably not necessarily always the strongest class of people for social skills necessarily, but I mean, like everything else, it's usually more about whether, you know, I get along with them or whether I work well with them, and less about whether they have some kind of abstractly good social skills, right? And so, you know, most of the time I don't think of it as like, does the person I'm working with have good social skills or do I have good social skills? It's usually more like, do we get along okay? And are we able to like resolve conflict productively, and are we able to like be on good terms with each other all the time and not be resentful or angry or whatever, right? And so, at least in my experience, I typically have not had much trouble getting along with the people I need to get along with in order to do work at like Mali. But, you know, your mileage may vary, and I think, like I said, it varies quite a bit from person to person. I have, like, there was one person that we worked with at one point, a contractor that I did not like working with, and we just don't work with them anymore for a number of reasons. But by and large, like almost everyone I've worked with, you know, either I adapt well enough to how they need me to work with them, or they adapt to me, and it's been okay. And so, yeah, I don't know, programming wise, I haven't had to cross that bridge. We might at some point, if Mali is, you know, more successful in the future in terms of what we end up doing in terms of, you know, if our products do well enough for us to hire a programmer or two at some point, then I'll have to obviously, take some of that more seriously in terms of what I would need to do for hiring a programmer. But at the moment, we only really ever hire artists. So yeah. All right, folks, I think we can safely call it a day, I suspect. So I'm going to go ahead and close down here. All right, thank you everyone for joining me for another episode of Handmade Hero. It's been a pleasure coding with you as always. If you want to follow along at home, you can always pre-order the game on handmadehero.org, and it comes with the source code if you want to play around with it. You can also support us on Patreon. You can go to our forum site, ask questions, look at the annotated episode guide. You can go use the tweetbot, which lets you know when we're going to be live. And I would also remind you that our time for tomorrow is a little bit different than what I initially announced. Due to I had to make some arrangements for something tomorrow evening, so I had to move the stream back. It was going to be the same time as it was today. It's going to be at 8 p.m. Instead, it's going to be at, I believe, 6 p.m. tomorrow. So, always check this guy if you want, or the tweetbot. Actually, I think the tweetbot has it as well. Yeah, so there it is. The tweetbot says it. So be aware of that. Also, Thursday, so 2 days from now, I will be doing a live stream with Sean McGrath, or SSSSSS McGrath on the chat, regarding free-to-play games. I'm not really sure what it's going to be about exactly, but he is working on a free-to-play game, and I think he wants to have a little bit of an angel devil on the shoulder conversation about it. So we will have that conversation. So that'll be immediately following Handmade Hero on Thursday. So Handmade Hero will start at 7. It'll go from 7 to 8:30, and then at 8:30, Sean will, I guess, Skype in, or however he wants to get himself into the stream, and we'll go from there. I also would say that finally kept having to do just make sure that everyone was nailed down for Handmade Con. There was just a few things, like last minute things, that weren't 100% settled, so I couldn't announce the speaker list with 100% certainty on Monday, but we actually got it 100% certain today, and so next Monday I will actually post the entire Handmade Con schedule with the times that everything will be happening at Handmade Con. So for those of you who already have tickets, you'll know exactly what you're doing. If you would like a sort of teaser way to figure that out, if you go to handmadehero.org before Monday, if you actually go to the tweetbot, you should see there's a little puzzler on here. And what I did is I sort of picked intentionally fairly obscure, I mean as obscure as you can really do with screenshots. I tried to pick like from potentially less notable or less easy to recognize games from people potentially, but sometimes that's hard to do. Basically what I did is I picked 2 screenshots from each of the 5 speakers who will be participating in Handmade Con 2015. And so if you want to figure out who the speakers are beforehand, you should be able to do it by scrutinizing this lovely little block. I won't say anything else about it, but on Monday you can see if you were right. Some of it's a little difficult, some of them are easier, but there you go. So there you have it. That's all the news from Handmade Hero Land. I'll be back here tomorrow. Again, it will be at 6 p.m., not 8 p.m. Due to a schedule change, but I will be back here doing a little more work on the debug system. Until then, I hope you guys have fun programming on your own, and I will see you on the internet. Take it easy, everyone.